I actually remember talking to you back in, I think, September last year. And you said something like, yeah, I don't think at the end of the year, no one is going to be using an IDE. And in my head, I was thinking like, that's crazy. That's never going to happen. Like I could imagine that happening on a 2-year time frame, something like that. But 2 months seemed extreme. And then 2 months later, I found myself not using an IDE anymore. And like the way that I was working had completely changed. It changed that I had not seen in the 30 years that I've been doing this type of work.
It's funny, internally it felt exactly the same way that it did externally.
Okay.
But we had a head start of like a few weeks.
Yeah.
That was it, but it felt exactly the same way. So, okay, here I wanted to start with, how did you get into coding?
My formal background is actually in biology, so I'm a molecular biologist by training. And in that area, when I was doing my PhD studies, we started having what was then considered big data. So we had a lot of data from genome sequencing. So I felt that I needed to improve my ability to do programming, essentially. So I switched over. What was intended to be a sabbatical year ended up being, I guess now, close to 30 years of being in this industry.
So fast forward to today, with all the change right now with agents and LLMs, I feel like your personal usage and Spotify usage is on the frontier of what I see in the industry. What was your first feel the AGI moment personally?
I think I've had a few, depending on a little bit of the problem that we were trying to solve. We started pretty early as LLMs came about to try to use them to automate code changes. And that was a real struggle to begin with. But after a while, as we started figuring out like how we can use LLMs and judges and whatnot, we started getting some pretty inspiring results from that.
And this was like a few years ago.
Yeah, it was pre-Claude and it was like early GPT days, something like that. And again, like the results we got then wasn't like we can fix all our problems, but it was giving an insight of like where this is heading in the future. Mm-hmm. So that was certainly one. I have to say, from my own personal coding, the real breakthrough moment was probably Opus 4 or 5 back in November, December. It went from being this like smart autocomplete to something that I could actually throw real problems at, and I didn't have to do all that much prompt engineering.
The biggest thing for me was also just not having to edit code anymore, because my workflow up to then was I have the model write, like maybe 80% of the code or 70% of the code, depending on the model. And then I always had to go into an IDE to do the last mile edits. Yep. And I just stopped having to do that.
Right.
And that was crazy.
Yeah.
But yeah, I think that's a big part of the reason that it felt like such a leap. What's your workflow like today? Like how do you use Quad Code? How does Spotify use Quad Code?
Yes, I use it in I'm going to say fairly vanilla way, I think. I run it in a bunch of Tmax sessions in a terminal. Usually have a bunch of agents running in the background whenever I do some work.
How many terminal tabs?
So I will have anything in between 5 and 10 tabs, and then I use some panes because I like to have a terminal where I can actually like git diff and whatnot. So I have this set up with a matrix of Claude sessions and matching terminals in a set of work trees that I work in. The way that we're set up is that we have a few very large monorepos, which we're gradually moving towards. But we still have thousands of small polyrepos for that remains. So most of my work happens in those monorepos. So I usually have a few Claudes and terminals going on there at any given point in time. And then when I need to dip into one of our polyrepos, I will open up a more temporary Claude session there.
Do you feel like one like monorepo or polyrepo is a better fit for Claude? Or
I was a bit worried, to be honest, about the monorepo setup and agents originally, because I think with some of the prior tools we've been using, we've been seeing issues with indexing and things like that. And these are fairly large repositories that our backend monorepo is more than 20 million lines of code. But turns out Claude works amazingly well in those repositories. And I think one of the things we found is how good Claude is looking at other code in the repository to get, I guess, inspiration for the problem you're trying to solve.
I wanted to ask about some of the infra that you built. So, at Spotify, obviously you built Honk.
Yep.
I feel like from the earliest days of experimenting with models to building Honk and building background agents on the agent SDK,
Yep.
you see the future before other people do. What is it about the culture or the people working on it that kind of leads to this? And just tell me that story and how has it been going?
5-6 years ago now, we identified that our code base was growing much, much faster than the number of engineers we had to support. That's like 7 times faster. So that meant that over time, we just had more and more code that we needed to maintain. And Spotify is a company that has an endless source of ideas of things we want to ship to our users. So being bogged down by our maintenance was not a good place to be in. So we started trying to automate as much of that maintenance as possible. A lot of that was pretty dull work, like migrating to the latest Java version or library update or whatever. A lot of it was moving from some API to some other API across all our code. So we built out this infrastructure that we call fleet management, which is all about, like, instead of imagining before that, when we were doing a migration, we would send out the migration description or tutorial to all our teams and ask them to do that migration manually for all of their components. And instead of doing that, we imagine, like, can we find ways where we can do mutations towards our entire code base instead, living in thousands of repositories?
Because every team was kind of doing the same thing.
Yeah. Hundreds of teams doing the same operation manually over thousands of components. So each of these migrations took months and months and months to complete. We could maybe do 10 of them a year. So we were barely keeping up with being on the supported version of the frameworks that we're on. So again, we started automating this. We built out all of this infrastructure to do this. We've merged millions and millions of those types of PRs, but they all relied on these like deterministic scripts that you would apply and that would make those code changes or configuration changes. And one of the things we found pretty early was code has an enormous API surface. So trying to make changes to code gets very complicated very quickly. So we pretty quickly ran into a ceiling of how complex changes we can do. Even switching out the method in API becomes pretty complicated when you can call that in 5 different ways.
So doing this with just traditional like static analysis, like AST transformation.
Exactly.
Because like, let's say there's an API, you alias it to a variable or something. Now you need kind of like variable and state tracking.
That's exactly right.
That's messy.
Yeah. So each script that we had to migrate code turned into thousands of lines of taking care of every edge case in that code. So that inspired us, as I mentioned before, pretty much as soon as the early LLMs came along of like, hey, these things, can we apply them to this problem? And early on, it didn't work at all that well. Partially because the models weren't good enough, partially because we were very naive in how we were trying to do it. We were basically just put the code in front of the model and try to get it one shot that change. So that didn't work. Over time, models improved and our thinking about how to do this improved. So we started applying LLMs as judge to make sure that the output was as intended. We started breaking down the problem, decomposing the problem in various ways. So many iterations of this and many internal hacks to try to take on this problem in different ways. We started consolidating that, and that then became what we now call Honk. It was a very different beast. Originally, it was not on top of Claude. It was more a bunch of homegrown type of things in there. But it was the first sort of light in the tunnel of like, yeah, this is actually a problem that we can solve. And then we've done many iterations on Honk. Yeah, so today we released what we call V2, but I think in reality it's V8 or something like that. We just didn't keep track of the iterations we did on it. And it started out as this like automate these code changes, schedule that and orchestrate over all our repositories. But pretty quickly engineers figured out that, hey, this is useful for other things as well. I want to mention this thing on Slack and have it do a task for me or all of those types of things. So today Honk has grown into being a much more ubiquitous tool for us.
Tell me about the architecture of Honk. Like what are the big pieces? So you talked about having, there's the agent that codes, and this is just built on the Claude agent SDK.
Yes.
And then you also have a verification step, like an agentic verifier. Tell me more about
So
that.
we used to have a judge in Honk, but we actually have removed that because we found that the agent and models just, again, going back to 4 or 5, got good enough that we didn't need a judge anymore. The judge was very important in the first iterations of Honk. So it made us go from, if I remember the numbers correctly, like roughly like 20-30% success rate on PRs to like 80% success rate. So,
Wow.
So it's a big change. But then again, as we talked about, the models caught up and the agent hardness caught up. So we have now eliminated that judge from Honk. So Honk architecturally is fairly simple. So it's the agent SDK running in a Kubernetes pod. It has access to a set of tools. It used to be prior to V2 that those tools were a predefined allow listed set of tools that we trusted to give to that agent. Now in V2, users can add their own tools, just auth those tools. So now the agent can use any of our internal tools. And one of the most important tools that it has access to is that it can run verification, like basically run CI builds. And it can run those both on Linux and Mac OS. So Mac OS is particularly important to us because any iOS development, for example, needs macOS builds.
Mm-hmm. And is this just building, or are you doing like a full, like open up the iOS simulator, have the model like start the app? Kind of how deep does it go?
It can do those types of tests. We definitely have cases where we integrate the simulator and Claude to automate things like going directly from designs in Figma to UI implementations. And we've been using that for porting, for example, our TV apps from our iOS apps.
I feel like verification it's one of these things that we talk about a lot.
Yeah.
But I think when you're doing this kind of closed loop development where it's an agent that it's given a task and then it has to maybe like fin out and break down the task, and it just needs to do a lot of work without a human in the loop.
Yes.
It's just the single most important thing.
Yeah.
And I feel like one of the common mistakes I see is companies underinvest in how well that verification loop works.
I think that's very true, and I think it's true for us as well. One of the major changes that we did in our engineering practices as part of that was to strengthen our test automation. We have divided our code base into many thousands of components. Each of those components have well-defined ownership, so it's owned by a particular team. And that team is fully responsible for that. They probably designed it originally, they implemented it, and they operate it. And part of that, prior to the investments we did in fleet management, was around like that team was in the loop for every change that got merged to their code base. And that meant that in some case we could be a bit sloppy on test automation because that team could always check every PR if they needed to. But with starting to automate PRs towards our source code, one of the things was we needed to change the expectations for teams. Like you might no longer be in the loop for these changes. We're going to be auto-merging most of these changes without you ever seeing the PR. So that meant then having to build out much better test automation to make sure that all our software could sort of survive those types of automated changes. Now zooming into where we are today, that's been very, very helpful for us because now we can throw agents at that and use the same verification that we had in place before.
There's one of these trade-offs that people talk about all the time in engineering of reliability and quality on one side and speed on the other side.
Yep.
And to me, it feels kind of like a false dichotomy because if you want to go faster, the thing that you need to do is you need to automate your quality practices so that it's better encoded. It's not in someone's head. It's actually like in a skill or in a Claude MD or in some set of MCPs. It's something that Claude can do.
Yep.
And that's ultimately what lets you go faster. And this is just another example of how in engineering, productivity is always about investing in infrastructure. It's not about working more hours. It's about just making the infrastructure better and better.
Yep.
And that sounds like what you're talking about.
We're seeing that we're keeping our quality metrics neutral while significantly improving our speed. But that does not come for free. We've needed to make these investments into test automation as we talked about. I think we're going to have to continue our investments into our reliability practices as well. Some of those are changing as part of this transition as well.
And I guess as you try to go kind of faster and faster and faster, you have to invest even more in reliability.
Yeah.
Just to keep pace.
That's exactly right. So we make something like 4,500 production deployments every day.
Oh.
So there's a lot of opportunity for things to go wrong. We need to have good practices around making sure that everything that ships into production has the quality that we want.
What's the idea with doing this many deployments? Is it kind of, in the past it was just continuous deployment and now maybe it's faster signal for the agent, or how are you thinking about it?
This is something we've always been optimizing for as long as Spotify has existed, I think. We want to be able to basically have an idea and for a developer to have an idea and be able to ship that into production as quickly as possible. That used to be weeks or months back a few years, and we've just continued to try to optimize that, and now it's an hour or something like that. Like as I mentioned before, we have lots of ideas. We want to validate and explore those ideas, and the faster we can get feedback on that. And in some cases that might be feedback from our internal users, in some cases it might be feedback from our external users. But in both of those cases, the faster we can iterate, we found that we both build better products and we're able to ship them faster to our users. Not every idea ship in an hour. Many ideas takes lots of exploration before we're able to ship them. But the notion of being able to get that quick validation is super important to us. And agents are certainly part of that loop as well.
So for Spotify, the engineering org is fairly big. It's like thousands of engineers, right?
Yeah, it's 2,900 engineers, something like that.
2,900 engineers. How do you think about, as you do all this stuff, how do you think about ROI, like measurements, just making sure you're moving in the right direction?
In terms of measuring ROI, it's been easy and we've seen very clear signals in that space. We're seeing a 75% plus improvement in PR frequency, for example, that we can directly attribute to AI tooling. And I think by now 73-ish% of PRs are directly attributed to being AI authored. So those types of metrics we're doing pretty well on. But then, of course, we want to connect that to user value and revenue.
And how do you measure something like that? Is it sort of like A/B tests or some kind of holdout, like case studies? Like how are you thinking about
that? So we want to basically be able to connect the deliverables that the engineers do, so PRs, deployments, into, we call them work items, so basically like the planned work that we have. And then that connects to A/B tests and rollouts. And then we're able to, from that, see basically attribute back to say this PR contributed to this DoD that we have, and that contributed to this user value. That's the idea, and we're trying to build those connections right now.
Yeah. I feel like back in the day, we've worked in developer productivity for a while. Like when you have a big team, you want to make them more productive.
Yep.
And I feel like back in the day, a big win was like a few percentage
single
points.
Percentage point.
Exactly.
Yeah.
If you're lucky enough to be able to measure that.
Yes.
And with the improvements nowadays, it's just so obvious to everyone. Yet, as engineers, we still want to measure it.
Yeah, I'm going to say the ROI discussion initially was fairly easy because we could see such large improvements. And but as the maturity is getting there and the costs have been improving, I think the precision around those ROI estimates, the expectations on the precision is going up as well. So that's why we're trying to improve how we can do that type of measurement.
Part of it is about the improvement in productivity, and then part of it is how much does it cost to get that improvement.
That's exactly right.
And now, people are seeing these many dozens or hundreds of percentage points of improvement, and now you really want to attribute it to figure out how many tokens did it take, how many hours did it take, what was the productive output.
Yeah, that's exactly right.
I want to end on maybe one question. What advice would you give your peers? What advice would you give to other CTOs and engineering leaders, like VPs of engineering at other companies?
What we've found is that these investments in foundational capabilities, we talked about test automation and verification. I'm going to say the same is true for, or another aspect that we've seen is standardization. So we've been driving, more consistent code bases, more alignment on the tools that we use, the frameworks that we use. And we've seen that this was originally investment we did to simplify things for humans and make humans more productive. But we've seen the same thing transition really well to agents as well. So if you have, I mentioned this before on Claude being able to find inspiration from other pieces of code in our monorepos. If they look in 10 different ways, Claude is going to be more confused. So we've been seeing the more consistency we have, the better our agents work. So I think if there's one advice I would give would be to not ignore those types of investments. You need to have the same sane engineering practices that we had before still applies in this new world. Might look different. There's a new actor being in your code base, but the fundamental seems to apply equally well. At least that's been the case in our environment.
What's your advice for engineers that maybe have been doing engineering work for a while? And I know Spotify has talked about engineers, like shipping PRs on the subway, which is really cool. So obviously engineering is changing. What's your advice to everyone that's in the middle of it and trying to figure it out?
Yeah, let me talk about this from a more personal angle, I think. So I'm someone who's always have truly enjoyed the problem-solving part of coding. This is going to sound as nerdy as it is, but like in my spare time, I will do like competitive programming at times because it's just like fun mental exercise. In the back of my head, I was always a bit worried, like we were talking about before, of like how this was completely changing the way we were working. And I was pretty worried about that from just my personal point of view. Like, am I going to miss that part of like the hard mental challenge of solving problems? And now I find myself having, 5 agents working in the background, and my way of interacting with them is very different from the way that I was working a year or two ago. And for me, that's turned out that I was wrong, and I like the thing that I like to do is solving problems, and the way that I solve those problems turn out to not be the most critical piece for me. This is always going to be personal for different people are going to have to make that transition in different ways. But I think focus on the types of problems that you're able to solve. I find myself both to be more productive in that I can bring more value from the work that I can do. I can also solve problems that I really couldn't solve before. I can jump into code bases that would have taken me days or weeks to get into before, and be contributing things that I just could not do before. So for me, that's been amazing. And again, it's going to look different for different people, but I think give it a shot and find the way that you can use those tools in the way that you like.
I feel like for me, I've seen this big shift from implementation time, because now, Claude does it in the background while I do other stuff.
Yeah.
And instead, what's filled up that time for me is thinking about what's next, talking to customers, and also like actually much more prototyping than I expected. And some of it is for external products, some of it is for internal automations. How has that shift, how's that change looked for you?
I think it's been similar for me. And yeah, we didn't talk about this, but one thing that we're making a big investment in is prototyping in particular. And this is targeted both towards, I'm going to say engineers, but also the non-engineering cohort. One of the things that Claude and similar tools has unlocked is to allow anyone to take their idea, whatever that idea is, express that in natural language, and have Claude then go implement that. So as folks started figuring this out, including, again, non-engineers, they started trying to do this in our real apps, and they're pretty complex beasts of code, but they were starting to see, again, like signs of light that they could do it. So we started a few months ago. We basically built out the infrastructure to make that simple. So today we have a very simple way of getting going to build an end-to-end prototype in our mobile apps and our backend. And we have an internal app store for those prototypes where you can share them and like take a look at someone else, try out someone else's prototype in your app. And that's been a real unlock for folks that maybe before, and again, including engineers that maybe weren't super familiar with how to build something in our mobile apps, to be able to express ideas that used to take motivating a bunch of engineers to try to build that for you. And now you can go in and within an hour or two, you have a working prototype that you can start sharing with people to show what that actual idea looks like in real life with users' real data and so on. So yeah, those types of things were unimaginable a year ago, and now we're doing them every day.
Yeah, I love that. Have you seen a shift in who's producing this? Is it yes. Like engineers doing it? Is it mostly coming from designers and product managers? How has that changed?
It's everyone. Up to one of our co-CEOs have prototypes in that app store at the moment. So it's actually been.
Is it good?
Yeah. There's a bunch of like our senior execs have built prototypes that are good. Like again, like ideas that they always had in the back of their head. They have an entire engineering team that could build that out, but that team is focused on other things. So for them to then be able to try something out more quickly than they could before and get a touch and feel for what this thing is going to look like, allows you to test out an idea in a day instead of weeks or months.
Niklas, thank you so much.